Well, so today we are going to start that wave optics. So you have two parts, right? One is wave optics and you have a ray optics. So first we will discuss about that wave optics. It's a very important part. We will get multiple questions from here. Okay. So in wave optics, if you see that syllabus, so white color चाहिए, ठीक है ना? So you have a wave optics. So if you see that syllabus of this wave optics, so first of all, we'll see that phenomena of interference. Interference. Okay. Then optical path retardation. Then you have a Fraunhofer diffraction. Okay. Then you have a resolving power. Then grating, diffracting grating. जी पतला करो. Okay. हाँ. Is it okay now? ठीक है. Diffracting grating. हाँ जी. This Fraunhofer diffraction. Fraunhofer. Fraunhofer diffraction. Then diffracting grating, and then you have a polarization. Okay. Polarization you have what kind of polarization? You have a linear polarization, then circular polarization, and you have elliptic polarization. Okay. And then you have a phenomena of double refraction. Phenomena of double refraction. And optical rotation. So these are the topic. Okay, today we are basically going to study. So first of all, you have interference. Okay, interference means superposition of waves. So you have multiple wave and having certain common properties of that wave. If they superimposed, then there will be phenomena of redistribution of intensity of that waves. If they superimpose, then you have a resultant wave. It will have redistribution of intensity. So that we are going to discuss in interference. Then what is the meaning of optical path retardation? Yes, tell me. So in that you have a light traveling in a, suppose you have a light that is traveling in a air. having some thickness x. Okay, and if the same light is traveling in a medium with same thickness, then it will take longer time as compared to air, right? So that's why there's a concept of optical path. Okay, that we'll discuss in detail. And then you have a phenomenon, that is called Fraunhofer diffraction. So basically Fraunhofer diffraction phenomena means what? There's a bending of light. Light will not always travel in a straight line. If light strike in an edge, then there will be kind of bending phenomena that we'll discuss. Okay, and based on this diffraction, there are various properties like resolving power and diffraction grating that we'll discuss. Then another properties of light that is called polarization. So polarization means if you see that light is means what? Say electromagnetic light means it's a transverse wave, right? Light means what? It's a transverse wave, right? Transverse wave means the frequency of oscillation, the direction of oscillation of electric field is perpendicular to direction of propagation of light. So in ग्रिफिथ का आपने लोगों ने फर्स्ट पेज में देखा होगा, राइट, कि EM वेव का ऐसे पिक्चर गिवन होती है, राइट. सो वी सी दैट डायरेक्शन ऑफ ऑसिलेशन ऑफ इलेक्ट्रिक फील्ड दैट इज परपेंडिकुलर टू द डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव, also the direction of oscillation of magnetic field that is perpendicular to the direction of propagation of light. Basically all these three are basically they are mutually perpendicular. So if you have a particle motion or oscillation of the particle that is perpendicular to the direction of motion of the wave, then that will be called what? Transverse wave. But longitudinal में क्या होती है? Parallel होती है, right? बट व्हाट इज द मीनिंग ऑफ पोलराइजेशन? जैसे आपका सपोज मान लो ऑर्डिनरी लाइट से जो आपका फोटोन इमिट हो रहा है ना, तो दैट लाइट इज इमिटिंग इन ऑल पॉसिबल डायरेक्शन लाइक ए स्फेरिकल. जो लाइट कोई पॉइंट सोर्स से या बल्ब से जो लाइट निकालते हैं दे ट्रैवलिंग इन ऑल पॉसिबल डायरेक्शन. इसका मतलब क्या है? ऑल पॉसिबल डायरेक्शन में जब लाइट ट्रैवल हो रहा है इसका मतलब क्या है? ऑल पॉसिबल डायरेक्शन में आपका इलेक्ट्रिक फील्ड का ऑसिलेशन हो रहा है. बट पोलराइजेशन फेनोमेना का मतलब क्या है? The phenomena of confinement of oscillation of electric field in a single direction, है ना. सारे अब अगर आप देखोगे लीनियर पोलराइजेशन, इलिप्टिकल पोलराइजेशन, सर्कुलर पोलराइजेशन, हर एक इसमें क्या है आपका जो इलेक्ट्रिक फील्ड का ऑसिलेशन है लाइट का दैट इज कन्फाइंड इन ए प्लेन, नॉट दैट लाइट दैट इलेक्ट्रिक फील्ड इज नॉट oscillating in all possible direction, but in polarization phenomena what is happening? Electric field is oscillating in a confined plane. In a plane they are oscillating. So that phenomena is called polarization. Okay? And if you see that in polarization we always discuss with what? We will always deal with electric field, not magnetic field. Can you tell me what is the reason behind that? If you see, you know that intensity of light कैसे आप define करते हो बताओ? We'll discuss in details. कैसे define करते हो? एम्पलीट्यूड का स्क्वायर. अगर देखोगे आप इलेक्ट्रिक फील्ड का जो एम्पलीट्यूड होती है EM वेव में क्या होती है? दैट इज C इंटू बी नॉट. यानी जो मैग्नेटिक फील्ड का एम्पलीट्यूड होती है दैट इज 1/c टाइम्स द मैग्नीट्यूड ऑफ एम्पलीट्यूड ऑफ मैग्नेटिक फील्ड इन EM वेव, दैट इज 1/c टाइम्स. तो आपको ये एम्पलीट्यूड दिखेगा. Amplitude associated with magnetic field in EM wave that is 1/c times. Can you imagine? 1/c means speed of light, that is of the order of 10⁻⁻8 times the amplitude of electric field. So the contribution of intensity in EM wave that is arising from where? That is majorly arising because of electric field. So that's why we, in polarization especially, we deal with what? Electric field. Why? Because the contribution of intensity is arising because of electric field. Do you get what I am trying to say? So we'll discuss all these topics, and this topic is really very very important to get that good rank. These topics are important. हर जैसे आपका 3 फेनोमेना है बेसिकली. एक आपका क्या है? इंटरफेरेंस है, एक आपका डिफ्रैक्शन है और एक आपका पोलराइजेशन है. हर एक टॉपिक से एटलीस्ट आप 2 क्वेश्चन मान सकते हो. तो 3 × 2 कितना है? 6 क्वेश्चन अराउंड यू विल गेट इन JAM एग्जाम. Okay. Now the book that I will follow So first, that you know that book, right? Ajay Ghatak. ठीक है? Another book is that book is also very very good. That is in JEST. Okay, these are the book that we are going to that I'll follow. These two books are very standard.
इसका वेटेज कितना होगा हमारा?
अगर कंप्लीट देखोगे है ना, ऑसिलेशन वेव्स एंड ऑप्टिक्स को मिला के अराउंड 17 मार्क्स का वेटेज है. 17 मार्क्स. ओके, सो वेरी वेटेज. हाँ, बहुत ही ज़्यादा इंपॉर्टेंट है ना. और इसको बहुत अच्छे से समझेंगे, ऐसा नहीं है मतलब कॉन्साइजली पढ़ेंगे हर एक टॉपिक को. हाँ, इजीली समझेंगे, है ना. और जहां पे भी समझ में नहीं आएगा वहां पे पूछ लीजिएगा, है ना. ओके, सो शैल वी स्टार्ट. सो फर्स्ट